In this video, we will study organic chemistry at Igcse level. Let us first compare organic compounds with inorganic compounds based on day-to-day examples. This is just to create awareness at a very beginning level. Organic inorganic compounds. So first let me write down some examples from daily life under organic compounds. The examples are coffee that we drink every day. It's an example of organic compound. We take Panadol every day, which is basically a paracetamol. So Panadol. All the dyes that we have different colors, dresses of different colors. So these dyes come from organic compounds. They are organic compounds, in fact. Soaps, all are organic compounds. Our DNA is also an organic compound. Paints that we use this is also an organic compound. Natural gas that we use at home for cooking, it is basically a methane gas, but commonly we call it as a natural gas. Natural gas. This is also an organic compound. Coming to inorganic compounds, table salt that we use on daily basis in making foods. Table salt, that is inorganic compound. It's not organic, it's inorganic compound. And acids such as hydrochloric acid is an example of inorganic compound. Carbon dioxide that we exhale while breathing is an example of inorganic compound. Water is also an inorganic compound. Diamond is an example of inorganic compound. Initially, it was believed that compounds coming from living things were organic compounds. Initially, organic compounds were compounds which were coming from living things. Any compound coming from living things were considered to be an organic compound. That was the initial thought. But now the definition has changed. Now organic compounds contain carbon atoms, but it has few exceptions, because carbon dioxide also contains carbon atom, but it is not organic compound. So carbon dioxide is an organic compound. Carbon monoxide is also an exception. It's not an organic compound. All the carbonates like sodium carbonate, calcium carbonate, they are not organic compounds. All bicarbonates are also not organic compounds. Now let's see what organic chemistry is. Considering above information, we can say organic chemistry is the study of carbon compounds, with some exceptions as identified above. With some exceptions as mentioned above. So before we jump into hydrocarbons, let's learn something about few terminologies which will be heavily used throughout our study. First of all, how organic compounds can be presented in different ways. The first thing is general formula. So general formula is a formula which represent the whole family of same type of organic compounds. So let me just give you the example of general formula. CnH2n plus 2. Now this general formula is used for a family of compound which is called alkanes. We will talk about it later on. Right now, just take it as an example to understand the concept of general formula. Represents family of specific type of compounds, of organic compounds. The next is empirical formula. Now, just to give an example, if you have a general formula of particular family of group is let's say C2H6. So if I simplify these numbers, 2 ones are 2, 2 3s are 6. So this will become CH3. So this is the empirical formula. So this empirical formula shows simplest whole number ratio of atoms of each element in a compound. So CH3 is an empirical formula for C2H6. The simplest whole number ratio of atoms in compound. So I just gave you example of CH3, which is the simplest ratios, shows simple ratio between carbon and hydrogen for C2H6 compound. I will give you another example. For example, CH4. Now CH4, here one carbon is connected with 4 hydrogens. So this particular compound is already in a simplest whole number ratio. You cannot further reduce it. So CH4 is an empirical formula also. This is also an example of empirical formula. If I take example of propane, for example. So we'll see if what is the empirical formula of that. C3. So here also 3 and 8, you cannot reduce it because the ratio has to be in whole number. 3 ones are 3, 3 to the 6, 3 3s are 9. So 8 is not coming in the table of 3, which means this cannot be further reduced. So C3H8 is also an empirical formula. Next is molecular formula. Molecular formula. It reflects the actual number of atoms of each element in a molecule. For example, I'll take the previous example C3H8. So here it shows 3 carbons are connected with 8 hydrogens. This is the actual combination of carbon atoms for propane. I also give an example of CH4, which is also a molecular formula as well as empirical formula. Here also one carbon is connected to 4 hydrogens. So this is the actual number of atoms connected with each other in a molecule. But C2H6 is a molecular formula of ethane. The empirical formula was CH3. So how do you write now? Here you have, it shows actual, not the simplest, actual number of atoms. Not the simplest, because we'll talk about simplest number of atoms, simplest ratio of atoms. So now we'll talk about displayed formula. Displayed formula. It specifically shows the arrangement of atoms and the bonds between them. For example, let me take the example of C2H6. So it will be written as C carbon and covalent bond between these 2 carbons. 1 hydrogen here, 1 hydrogen here, 1 hydrogen here. Hydrogen, 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 hydrogen. So this C2H6, this is a displayed formula of C2H6. So how are we going to define it? It shows arrangement of atoms and bonds between them, and bonds between them. It shows how the atoms are arranged. 3 hydrogen with the first carbon, 3 hydrogen second carbon, and they all have single bonds between them, single covalent bond. So another terminology which we need to be aware of is structural formula. The structural formula, let me just give an example. I can write this same ethane in this form. C H3 and CH3. So this will just show the arrangement, carbon by carbon arrangement, only connection with carbon, and all the other groups or molecules attached to carbon will be reflected just next to the carbon like this. So this is a structural formula. Shows arrangement of atoms, carbon by carbon, whereas other groups connected with these carbon will be just reflected with them. So the next term which we must know is homologous series. So homologous series is group of compounds which can be represented by same general formula. Which can be represented by same general formula. Using general formula, we can get molecular formula of different members of the specific homologous series. For example, CnH2n plus 2 is a general formula of homologous series called alkane. Alkanes. So here, if you put n is equal to 1, you will get C1H4, CH4. This is called methane. This is the first member of the family of alkanes. If you put n is equal to 2, you get C2H6, which is ethane. You can enter 3, it will be C3H8, that will give you propane. So another terminology we have to learn about is called is a functional group. What is a functional group? Let me give definition first. An atom or group of atoms an atom or group of atoms that determines chemical properties of a compound. Chemical properties of a compound. It means a homologous series which has the same functional group. It will show if you take any member of that particular family, it will react almost in a similar way like other family members. Same homologous series has same functional group. Now I'll just give you an example. For example, alkene, which has a general formula of CnH2n. First family member is C2H4. It can be written as, if I reflect in display formula, it can be reflected as C double bond H2 H2. Another member is C3H6. It is C double bond C, and then C will have H2 here, H3 here, H here. You don't get confused how I am writing all of them over here. 2 hydrogen here, 1 here. We will cover when we will study hydrocarbons. But right now I just want to highlight the term functional group. I want to explain that. So if you notice that ethene has got a double bond, propene has also got a double bond. If I'll take more family members, the quality of alkene is that they will have at least one double bond. So that's why this particular functional group alkene will have similar kind of chemical properties. They will react with other compounds in a same way because of this double bond. Similarly, I'll give you another example from the functional group carboxylic acid. Carboxylic acid. That's also another functional group. If I take first example, HCOOH. This family will always have a valency, this dash, COOH. That will be there, at least one of this will be there in any of the carboxylic acid family. I will take another one, CH3COOH. So COOH. So this is formic acid, this is ethanoic acid. So because of this COOH, they are specific to our carboxylic acid, and they will have a similar chemical properties. They will react in a similar way with other chemical compounds. So now I will cover one more part, coding. Or you can call it naming. Naming carbon chain. For example, if there is only one carbon, if the chain has got only one carbon, we call it meth. We'll call it meth. That's why in CH4, the name of CH4 was methane. If there are two carbons, we call it, it's called eth. Now C2H6 is called ethane. And also, since it is from the family of alkanes, that's why it is called ethane. This C2H4, but since this is from the family of alkenes, which has at least one double bond, that's why it is called ethene. Similarly, any functional group you can take, but depending upon the number of carbons, you will have to use eth. In the same way, if there are 3 carbons, for 3 carbon, the code is prop. I'll give you an example. CH3, CH2, OH. So this has got 3 carbons, which will make it prop. But functional group is OH, which is alcohol. All the alcohol, they have at least one OH group. So the functional group is OH. The homologous series is OH group. So that's what is called propanol. We'll cover in detail when we'll study alcohol. But right now, my focus is on number of carbons. So for 3 carbons, we are using prop. If we have 4 carbons, in the same way, we use the code but. In English, you call it but when we will use, called but. For 5 carbons, we use pent. Pentane, pentene, pentanol. C6, we use the term hex. If you use 6 carbon with the alkane family, it will be hexane. With alkene family, hexene. With alcohol family, hexanol. Carboxylic acid family, hexanoic acid. We'll cover naming in more details in another video. But right now, this is just a few terminologies which were very basic before we start our hydrocarbons properly.